Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today I wanted to get back into working with this Olive 5, or the power supply for the Olive 5, and this is that Hiraga power supply. So wanted to jump back in this video, and I started cleaning out my storage and I found this AC power supply, but I went to power it up and it doesn't work. Well, so it gives an opportunity to open it up, look inside, and see what's wrong. Maybe it's just, well, there's a fuse on the back, that's okay. I don't know. Now, it could be the Variac, big old guy on the knobs, burned up. I don't know. Hopefully, it's something simple because it's been years since I've used it. Let's open it up, take a look. Alright, one last screw. There's 3 screws on each side and 3 screws in the back. Now, since this thing has been in storage for some time, and I don't know what's going to be in here. Let's open it up and see if there's any creatures. Little cobwebbies down. Not too bad though. Well, actually, yeah, it looks like there was a guy that made his home in here. But by the way, I don't see anything obviously wrong right now. Oh, look, there's a fuse. Awesome. Look up here. Yeah. Now that's kind of black. Hopefully that's yeah, hopefully the windings are okay, right? But you know what? That looks hopeful. Maybe it's just something simple. See, there is this fuse right here. It's an inline fuse, and I've already checked this guy. It's a slow blow. But this one is connected to the load probably. I don't see anything smoked right now, but let's vacuum and clean this thing out. Alright guys, so I cleaned it up a little bit. I'm going to clean it up a little bit more, but I wanted to get in here and start looking at things. And you know, I see this big old 1 ohm resistor down here, and what is that, a 51K or something there. And this fuse, that seems to be the most obvious thing, right? So, yeah, look at that little resistor here. That guy, nothing looks like burnt or anything. It does look like there's a little bit of darkness on that glass right there. See that? Let me zoom in on that fuse. And if you see what I mean, it looks like the glass is a little bit darkened right there. Right? Looks like it's a slow blow type, and it does say, I saw 3 amps somewhere. There's 3 amp on the transformer over here, right down in here if you can see that. It looks like 30 kVA max. It's actually, I think that actually says 2.25 amps, input 120. So on the back unit back here, there's a sticker that says 3 amps max, but look, there's another sticker right here. Let's come down here. And you see that? And that right there says slow blow 3 amp fuse. I don't know if I have one. Let's see. Well, first of all, let's measure this guy. Alright, let's see if you can see that. And let's do a continuity test. I got it on continuity, the buzzer's on. Yep. Buzzer's on. Not like that, guys. Like this. Yeah, you don't do continuity like this. I don't ever see anybody do that. And look, no beeper. But yeah, well, there we go. Now, isn't that interesting? Because I believe the continuity, you know, we're between where the threshold of giving a buzzer and just giving ohms, I think it's 30 ohms on this. So this is well below that. It should be just beeping, but look at that. It actually has to think for a minute. So I think even though that's saying 10 ohms, that just seems wrong. Okay, here's a slow blow I just took out of the back of the unit. It's a little bit different type, but look at that. Wait, hold on. Oh yeah, there's how we do continuity. I like to make fun of that. But yeah, so that's a slow blow. Huh, So this guy, definitely 10 ohms seems to be too much, guys. You know what? Just for fun, I'm going to go ahead and plug this guy in, and we'll see if we see an open voltage there. We should see 120 volts, or if this fuse is just kind of in between doing something weird, we'll see something like that too. So let's put this on voltage, AC, and I'll go plug it in. Alright, you know what? Before I plug it in, I thought something else. Let's just, for fun, trace the continuity through the system, make sure things are working okay. Okay, so that fuse is definitely short. Okay, and then, so it comes to this fuse, the line power, that's the hot. The neutral goes down here, and then it goes up to the transformer, and it comes up to this variac. So that's the neutral, that's the return, and then the green wire, if you see down here, goes right to the chassis, which it should. And maybe what I should do is clean that up too, make sure that's a clean connection. But, well, just for fun, while we're here, let me go to that, and I'll go to something else on the chassis. Like a couple ohms maybe. Let's go to something else that's maybe a better connection. Yeah, yeah, that looks like a good chassis connection. I'm going to the transformer, so that's probably good. It's got one of those star washers, I can see, those really gnarly looking things. See that? So it bites into the metal. But it does look like a little bit of corrosion maybe. Yeah, a little bit of rustus. Alright, well anyway, let's go back to tracing this thing out. So we got green wire, white wire, the black wire's the one with fuses in it. Okay, comes up here to the panel, right? You can see that, right? It comes right up here to the switch. Let me move the camera. Hey guys, little commercial break. Just want to go over this circuit so you can see what we're going to troubleshoot. We have 3 wires coming in, black, white, and green coming in the power cord. The green comes immediately in to the chassis where it should. And that has to make a good connection in case something here shorts to the chassis, that it goes back and it pulls the circuit breaker. Okay, so we're going to check that out. But the black wire comes into a fuse, and that's on the exterior of the panel, and then it goes through a switch, and then on the other side of the switch we have 100K that lights up this lamp, this AC powered lamp. Okay, and it's just right across the line to neutral. And then also across the line to neutral is our variac. And the wiper of the variac comes off and goes through a fuse, that's internal. And then powers up the primary side of this transformer. Okay? On the secondary side of the transformer, we come off and we go through a 1 ohm resistor. That's a big old resistor there. And that's for current sensing. And then power comes out. Okay, I mean it's 1 ohm, but then again we're only, you know, gonna burn about 1.5 amps. So that could get hot if we have 1.5 amps going through there, and you know, for a long time. That's a pretty big resistor. It's probably, I'm guessing, 5-watt resistor. Maybe it's more. And anyway, then the white wire comes off the transformer and goes to the output, and then we have a green wire going to the output too that's tied to the chassis. But this is isolated from this side. Okay, now there's also a 51K resistor coming off the white wire going to this PCB board. So we have 2 wires on either side of the resistor here on the 1 ohm, so it can sense current. And then sense voltage, we need this wire and this one. And so then on the PCB there's a switch that PCB is actually mounted so that the switch is mounted on the board, and it's right below the meter, so you can, you know, switch between voltage and current reading on the meter. And then there's 2 one-turn pots on that PCB board, so you can control you can calibrate the voltage and calibrate the current. Okay, that's basically it. It's a little small 300 VA guy, so it's not a lot of power, but It's enough. What's nice is we can bring up power slow and we can watch things, make sure everything's working okay, and be safer that way. So yeah, that's what this B&K. And incidentally, this B&K just happened to be made in the USA. It's pretty old. That's how old it is. Alright, let's get back to it. Alright guys, so you can see the switch, right? Okay, so the black wire comes up there, and there's only one other wire coming off the switch going to the other side of this, which is our variac. Okay, so it's like a little transformer winding. See the little swiper here? So this guy picks up, so we've got the voltage across the two terminals, and then this guy's our center voltage, our variable voltage. Okay, so just to show you how that works in case you're not familiar with that, you got power coming up here going to either side of this lug, and the power coming off of it is tied to this guy, and that's this winding right here, or that's this piece of metal coming up here to the fuse, going back to this terminal, and eventually going out to this output jack. Okay, alright, let me zoom out a little bit so you can see everything. Okay, so you can see this wire coming to this guy, and then it leaves off the center one. Okay, alright guys, so the toggle switch is in the down position. I don't know if you can see that slide right there, and so when I slide in the down position, it connects these. Look at that point. I think it's, yeah, it looks pretty good. I was gonna say it's a dirty connection. Okay, that looks like it's making. Okay, now let's go in the on position, and then I should be able to go to the center down to here. It seems like when I push this terminal, you know what, it seems like I think this switch is really dirty, because when I push the terminal here, I'll just go to the wire softly. I'll go over here. Look at that. But when I push the terminal, if I go back over the other, oh, you know what? There's a little rubber there. Yeah, you know what? I'm going to have to investigate this. This switch looks dirty. If I go to the top side, if I just touch it like that, look at that. But if I push, well, hold on. Yeah, this switch definitely seems to be dirty. I'll move it a few times. Okay. Look at that. But if I push, yeah, you know what? I wonder if it's that switch, not the fuse, actually. Let's go back to the fuse. It's like 10 ohms though. That seems to be too high. Alright guys. Here, let's go back to the fuse. Now you can see the meter. I mean, 10 ohms does seem to be high, but that switch seems like it has problems too. Let me see if I can clean it up. Okay guys, what I see on this switch, let me bring this up to you. Okay, you notice the switch, I bring this little insulative layer out, and see these little fingers that hold this switch tight? This little board right here has the contacts. And see these little fingers right here? They're kind of not flattened out. So I think I can push them square. I think I can push these things in. Let's see. Yeah, I felt that push right in. Okay, yeah, you see that? I don't know if you see that on camera, but I'm going to push this guy in. Definitely felt those guys get pushed flat, and I can see them too. Okay, here, let me try to get the other two. Alright, so maybe you could see where I push these guys in to push this piece of phenolic. I think it's phenolic, some kind of insulative material with the little contacts on it. So I'm going to reach across and try to push those other contacts up. Okay, right in here where I can feel it. Okay, now let me get down. Okay, I'm gonna have to try to reach across to get the other one up. Alright guys, so I think that pushed it up. Now I'll just push this insulated material back up there. Maybe I'll flay out these little pins here that we're not using. Now you know what guys, when I'm building something like this, all these other pins are unused because they're only using one contact. What I would do, since these two on this side are doing exactly the same thing as this one, I'd tie these two center posts together and these two bottom legs together. So you let the switch carry current on both sides of it. Why not, right? And also reliability factors for just things like this. Here, now let's go see when we take those measurements again. You'll hear well, maybe you'll hear and see. Alright, let's go do that again. And I'm going to just lightly touch them. Oh yeah. No problem there. Look, point. Yeah, there we go. Just lightly touch. Nope, these two aren't doing it though. Boy, that's disappointing. There could be some oxide for sure on these things, so I'm going to just try to rub it off. Okay, let's try that again. I mean, we're not using this side, but it's just... Wow. Those things are just flaky, and it could be, who knows, me bending these around maybe have caused a problem. But that one's definitely doing a lot better. Now I'll put the switch in the opposite position, and let's check the other contacts. That looks better. So does that. So if I really needed to, I could take the switch out, flip it around, and do it. But I think I'm going to work with this a little bit more, and I might even solder a wire to bridge those two bottom contacts. Alright guys, unused contact on this side. It actually has a visible tarnish on it. So if I go to the top edge where I'm just touching metal, then it makes good contact. So they're both doing great, and I flip it over. The other, yeah, so that switch is in a lot better shape. This guy, however, okay, now let's go ahead and apply some voltage and do some more troubleshooting. Alright guys, so I've got my inductance meter here, the SEM DT-9935, across the output terminals, and you can see that it's a 790 millihenry inductor from end to end. And then of course when we dial it down, it goes down to, go all the way down to 0, as we end up essentially shorting it out when we go to the bottom. And then it turns into 2.4 ohms. Okay, so that is from output. So if I just go from input, it says about 600. It kind of goes up to about 635, I think, when it sits there and settles down. Yeah, so you can kind of see there. So I'm kind of wondering, even though it doesn't have the extra terminal that some Variacs have, so you can go a little bit higher in voltage, I kind of wonder if it actually does. We'll have to power it up to see. But the output terminal, pin 3, input terminals, this white wire goes to the one side of the Variac, and then this white wire comes up and goes into the transformer. So that's one side, and then the input power comes from this black wire down here up through the switch to pin 4. So pins 1 and 4 are the power, as you can see there. And then pin 2 has nothing connected, and pin 3 is the output. So then we have also the power comes up, you see it goes through the resistor, through the lamp, and then back to neutral. So that's the lamp showing we have power. Then looking down here, this big 1 ohm resistor is the current sense, and this guy here, that resistor is the voltage sense. So the output winding of this transformer, one end goes down to the one end of this 1 ohm resistor, and the output is a black wire going to the output. So this, and then we have a red wire and a black wire coming off each side of that 1 ohm resistor coming up to the board up here. The resistor, the blue wire coming off of this comes down and it jumpers over to the white wire, which goes to the output, and then we also have this resistor that comes to this blue wire that goes over to the board, and that's the voltage sense. So then down on the board we have an amp setting and a volt setting and a switch. You can see the switch here that's from the front panel where we select voltage or current. Yeah, so then down the board you can see the amps pot and the volts pot, so we can adjust the meter for amps and volts. And there's a switch right here that is on the board that's accessible from the front panel to switch between volts and current for the meter here. Okay, so that's pretty much all the stuff inside. Let's go ahead and start testing this thing. Alright guys, I think what we want to do is put this on AC. I'm going to go ahead and plug it in, and then what I want to do is measure the voltage across this fuse and see if it's going to be a low voltage or if we're going to have some voltage there. Okay, the switch is turned off. Power switch is in the off position on the front. Alright, and go ahead and hold these probes here and then hit the power switch on. Okay, it's on. I don't see any voltage across this switch or this fuse, so maybe it was just a switch on the front panel. Alright, I put the probes on the front panel. I didn't see any voltage, so I think what the problem was, I had the variac down low. So let's try that again. I'm going to try to hold these here. Yeah, that's what the problem is. I have 60 hertz here, by the way. Look at that. There's 10 volt drop across the fuse. Yeah, there's 100. Oh yeah, and this dial actually does go. Whoops. 139. Yeah, this meter beeps at me and shows me a high voltage thing. So, yep, that fuse is bad, guys. Okay, I just happen to have another fuse. Just one in this box, if I can even open it, which actually has what we want. So I'll put this in here. Alright guys, I just soldered this back in there and down here, and yeah, I think I'll just kind of place it out here in the middle, and I think it's good to go. Alright guys, I got the leads of this multimeter in the front of the, well, at least I'm trying to, well, here I'm going to have to hold them, I guess. It's kind of hard to get in there. Okay, I'm going to go ahead and turn on the power switch. And I don't see anything yet. Let me see if the... I see the voltage coming up, but I must not be making... There we go. I wasn't making contact. Hear it humming. Everything... Man... Okay, everything looks good. Turn off the switch. Alright, I'm going to put it back together. Okay guys, I thought since we have it open, may as well, you know, especially since the age of this thing, I thought we could check to see the voltage and the current. Okay, this button's out right now. The switch is out down here, so that's for volts. See if I make contact in here. Okay, turn on the switch. Crank it up. Okay, I got a beep. Seeing some voltage. Looks like it's pretty good. Okay, that's about 40 volt. Okay, that's about 40 right there. Yeah, it looks like it might be off. I think it's probably good to go to full scale and adjust it. Or maybe at the top. I don't know. I mean, right there, that looks like it's on pretty good. But you know, probably when I'm at 120 is where I want it to be most accurate. And actually, you know what, guys, that looks pretty darn good. Right? Yeah, those adjustment pots are like single turn pots. They're not like 20 turn pots. So you know what? I'm thinking that looks pretty good. Oh look, somebody put a mark there at one time. Who knows, maybe I did. But that mark is all the way over there. 125. I don't know if I would have put that mark there. I would have put it at 120 or 115. Anyway, I don't know why the mark's there because the scale is pretty good. Hey guys. Alright, I just want to point out that when the switch is on, you get the little lamp turning on too. Okay guys, so I have this plug and I've got it connected to my load bank over here, and I've got it set for 119.9 ohms. Okay, switch is off, but even with the switch off, when I plug this in, it connects it to the secondary side of the transformer, so it gives me, you know, wrong reading, of course. So it's basically 120 volts or 120 ohms, 119.9. So I'm gonna bring this up to 120 volts, and then the current should give me 1 amp. So let's see. Alright guys, hey guys, I had a problem with the microphone, sorry about that, but I put this meter here in line with the current, and then I just adjusted the current and the voltage. So 120 and 1 amp. So yeah, now the pots down here are like, say, a 1-turn pot, so they're not super precise, but that's, you know, if you need precision, we'll put a meter like this to our circuit. This is just kind of, we'll just have to know that this isn't super reliable, especially if you know, this button, I noticed I had to do it a few times to get to really lock in. So yeah, maybe with some use, this guy will get a little more solid too. It's already looking way better. Hey guys, one thing to note is the fuse I removed, the element, I can see it now, it's burned open, and I think just unsoldering it, maybe jostling it around, has opened it up. You can see there. Yeah, maybe you can see the element in there now. Here's another thing you may have noticed. This was sitting on my bench, and that just fell off of there. The epoxy that held it on has just gotten dried up and old, and just moved it around, it had fallen out. So I'll epoxy that back. Alright, well hey, now we have this little 300 VA Variac. Well, it's got an ISA transformer in it. Kind of a small little guy. I've seen these on eBay. I think they're around a couple $100 on eBay. It looks like it's not in too bad a shape. I've had it for a long time, and it must have blown a fuse testing it at one point and sat it on the shelf. I made a new one. I'll show you that one in another video. It's a little bit bigger Variac inside. But alright guys, hey, thanks, hope that was helpful. And now we'll get back to our Hiraga Power Supply for our Aleph amplifier. Get that project going. Okay. Oh, hey, thanks to my patrons for all your support, and appreciate that. You can become a patron for as little as $1 a month, and I want to thank everybody for watching the videos and supporting the channel. That's awesome, all your comments and everything. Oh, and give the video a thumbs up. That helps you with the YouTube analytics and all that kind of stuff, and share it, all that kind of stuff. Alright, hey guys, thanks for watching. See you next time.